Okay. So welcome everyone to the Dev series. So today I'll be talking about CQRS, and before just diving into the topic itself, let's just talk about why we are actually talking about CQRS. What problem we're actually trying to solve. So CQRS is actually just command query responsibility segregation, whose main goal is to optimize and scale the large scale enterprise applications. So this is just one of the approach, and in our further series, we'll be talking about other topics as well related to scaling. So let's begin. So we have been working on a lot of large scale enterprise applications, and the very first thing that we do, or the very first thing that we achieve while building such application is to make it work and to make it right. But just making those application workable, it's just not enough, because we're pretty much sure that with time, few things happen. Number one, the data increases. Number two, the user base increases, and when it happens, the request from those end users to our system definitely increases. So if you see the curve, the the request or the user exponentially increases, whereas the performance lags when it happens. So should we just compromise that? I don't think that's what we should be doing. So there are a lot of approaches uh, for optimizing and scaling our systems. So just we can just take an example of our um, okay, we can just take an example of our Spiralogics as well. So we have been involved in a lot of projects which are maybe around 10 to 15 years older as well. So out of these 10 to 15 years of time period, we have seen how much the data has grown, how much the user has grown, and with that, the system lags with all these data and with time. So we have always been looking forward to how we can optimize it, correct? So we need to always upscale or level up our systems from we have made it work to we can make it work even much more faster, and we can optimize it. So out of many approaches, there are a lot of approaches, like we can implement horizontal scaling, we can implement vertical scaling. I mean, which means we can just increase the server capacity, we can increase the storage and RAM and all, but that's not always enough. So that's not always recommended as well. So we can implement other horizontal scalings, like and we can also optimize our codes, we can optimize our queries, we can implement a lot of other options like microservices and all. But here in this session, we'll be focusing on a special kind of complex softwares or complex systems like LinkedIn, or maybe like a TikTok. So before moving on, I'd just like you guys to ask how many of you guys use TikTok application? Anyone?
No,
Yes,
I
type.
I don't
don't.
use it, but my wife does frequently.
Okay,
Very heavily type.
very heavy.
Yeah.
Use it
Himanshu.
sometimes, but I
Okay,
try to avoid
sometimes.
it.
Oh, okay. So, I've got another question for you. So, how often do you guys use it? For the people who use it, this question belong for you guys. Okay,
45
Himanshu.
hours.
Okay, Himanshu, how
Yes,
often do
type.
you use it?
Uh, maybe for 2 hours a day.
2 hours a day. And how often do you post your videos? Do you have any TikTok videos posted on your account?
I don't post, but yeah, I watch a lot.
Okay, so you watch a lot, but you do not post it. You don't have a single
Mhm.
video, or you're just
That
hiding it?
yeah, I have a lot of those in my drafts.
Okay, so you're not posting it. Okay, right?
Yes.
Okay, so I'll just assume that every one of us use TikTok similar to you. So we have been using a lot of I mean, we have been using TikTok a lot of our times, maybe for a lot of minutes or hours. but we rarely post videos. And if we do, maybe per day we approximately post one video to five video. But while it comes about retrieving information, while scrolling the for you page, we do it a lot, maybe for an hour or two, just like Himanshu, right? So let me just rephrase what I've said, and uh, I'll just say video post to data write to a system, and video retrieve from a for you page to a data retrieve or data read. So if you just compare these two things, you'd see the ratio of video post to a video retrieve. That means data write to a data read, is there's a vast difference between these two things, right? Maybe the ratio is around 1 is to million, or maybe even more. So if you just compare, take a data of a huge amount of millions of data, so that could be the ratio, correct? So here in the CQRS system, we are trying to solve, or what I would say is we're trying to optimize such systems where the data write to data read is the ratio is 1 is to million. So let's start our topic now. So what is command queries responsibility segregation actually is? It's actually a software architectural pattern that separates the responsibilities of write and read operations. So the name itself says that it's a segregation of the responsibility of command and query. Simple, right? And now, what is command and what is query? These two things are the main things that we need to know. So we'll go further on details on these topics. But before that, let's see this diagram. This is a CQRS diagram. So here on the right, you can see there's command. On the left, there is a query, right? So on the command, you can see there's a post, put, patch, and delete HTTP request that has been sent to a product command service. So let's take an example of an e-commerce website for now. So here, let's say the user is sending a post request to a product command service. Maybe he's calling add product command service. So what happens is through this product command service, it will post some data related to product to a database on the right. Let's call it a write database. Okay. So on the left, you can see there's a query. It's sending a HTTP GET request. There's a product query service over there. Let's assume for the e-commerce website, it's retrieving the product summary that we've just added through a command. So it's pointing to a read database. So, so if you see there's something, uh, some circle between the read database and write database. So what it actually does is it will synchronize all the changes that has come from the command section and make it synchronized to the read section, so that whenever we are retrieving information from the read database, we are always getting the updated information. So we'll talk further about this in details. Let's just move forward. So command. So what exactly is command? So basically, there are four main actions that we perform to our database, which are CRUD operation, right? We are very much familiar with the CRUD operation: create, retrieve, update, and delete. So out of these, create, update, and delete request. So these actions will always make some changes in the database. It either adds a new record or updates the existing record, or maybe it deletes the record. So whatever it does, it will change what is already there in the database or in the system. So it's the action that changes the state of the system. So these are the actions like creating, updating, and deleting data, as I've already said. And it should process the incoming command and updates the domain model accordingly. So the query. So So as I've already talked about the CRUD operation, so create, update, and delete, it goes to a command section. The only thing that's remaining is retrieve, right? So it includes the actions that retrieve data from the database. So whose only task is to fetch information without changing its state. It should not make any changes in the database. Only its only job is to retrieve whatever is there in the database. That is it. So it involves data denormalization and storing data. So that means we need to maintain the read database in such a way that whatever or whenever data that we are fetching from the database, it should be much more efficiently, and it should the data should come much more faster. Okay, so now benefits of CQRS. So there are a lot of benefits of CQRS, and these are the four main benefits that I'll be talking about here. So the first one is performance. So reads and write models can be optimized. So that means since we're segregating the read and write model, so whenever I'm saying the segregation of read and write, I'll be focusing on two things. The first one is we we are segregating the code itself. We're segregating on the code level, and the second thing is we are segregating on the database level. So we can either just do the code separation, or if we are implementing multiple database, we can segregate the database as well. So when we are segregating it, we can make changes in each of the chunk, each of the section, and optimize it to get the better performance. And second thing is scalability. So it can be scaled independently, and it allows for horizontal scaling. So that means since we are having two different database, so that means as I've already said, we will be having very limited write request, but a lot more read request, right? So for that case, we can just leave the write database as it is, or read section as it is, and we can increase the number of database for the read operation. So it will also increase the performance. So it provides better option for scalability, right? And the third thing is maintainability. So it leads to a cleaner and more maintainable code, and it simplifies logic. Why? Because we're segregating each stuff, and we're making it small chunks of commands or queries. So it will be much smaller and cleaner code, and it will be very easier to maintain the codes as well. And the last one is flexibility. So it allows different data storage solutions for read and writes. So what does that mean? So I have already talked about having multiple number of database, but now we can also say that we can have multiple different types of database, right? So there are a lot of different types of database, like relational, non-relational, and different options for that. So some database could be very much efficient for the read operation, but not for write operation, and vice versa. So we can select which database to be used for the read operation, and we can select another different database for the write operation, so which suits it better. So it's much more flexible. So now challenges and consideration. So we've already discussed about the benefits. So now we'll be talking about the challenges and consideration. So there are few challenges and consideration that we have to keep in mind while we are deciding to implement CQRS or not. So these are a few of them. So the first one is increased complexity. So that means whenever we are implementing CQRS, we will be having multiple different chunks, or we are segregating stuff. So as compared to our traditional approach, where we are only focusing on one database or one model, here we are focusing on two different things. So we need to design for different models, and we need to manage everything. And another thing is, as I've already talked earlier, we need to synchronize the write database with the read database. So it also increase some extra complexity as compared to our traditional approach. And the data synchronization. So synchronizing data should be eventual, data through eventual consistency mechanism. So what is eventual consistency mechanism? So to elaborate on that, so so uh, as uh, uh, we can take a reference to the first diagram that I've shown. So we had two database for write and read, and there was some mechanism for synchronization, right? So that synchronization mechanism will definitely take its time. Maybe it may take some millisecond to seconds or some minutes depending on different scenarios, right? So there will definitely be some time lag between synchronizing the data from write to read. So we need to consider that as well. And for there might be some systems who cannot tolerate that time lag, and for those systems they should not be implementing CQRS. Number third, operational challenges. Managing multiple separate models, ensuring model availability and performance require additional infrastructure, monitoring, and maintenance effort. So this means having multiple number of database, a multiple number of um, models means we need to plan accordingly for all those database to be available at all the time. We need to check the performance, and as a developer also the user, uh, the one who is developing the system need to have all those information regarding the topics of having of dealing with multiple database, multiple model, and synchronizing mechanisms. So there are a lot of operational challenges as well. And the fourth one is domain complexity. It's suited for complex domains with distinct read and write. So this is a very important thing that we need to keep in mind, or I would say a very important consideration, because we have already talked about the benefits, and just taking that benefit into our mind, we should not be implementing a CQRS in each and every kind of project. We should always compare the benefits with the challenges and consideration. For the simple projects, we can ignore the CQRS, because for the simple system there will be very less data, less user, and less request, and for that we should keep it as it is, because it will only increase the complexity. So the real world examples. So the first one is Amazon. So these I've actually listed only four of the many real world examples. So these four are actually currently implementing CQRS to improve their performance and to scale the system. So Amazon, it separates the model for reading and writing product catalog, inventory management, and order processing system. And similarly, the LinkedIn, it separates the right side to a read side, where right side consists of a user updating and sending message and managing connections and stuff, whereas in the read side it consists of user retrieving user profile, news feeds, search results, and all. And we have the Netflix next. So it also segregates the read and write side. So in the right side it consists of user account update, content recommendation, and all. But on the read side it has it consists of search functionality, personalized recommendations, and all. Similarly, Uber also handles its massive volume of real-time ride request and driver dispatching by implementing CQRS as well. So now the best practices. So while implementing CQRS, we should follow these best practices. So the first one is we need to clearly define the responsibilities of command and query. This is the very important thing that we need to keep in mind. And the second thing is we should design small and very focused command. And the third is we need to optimize the read model for query performance. So that whenever we are retrieving information, it should be faster and efficient. And the fourth one is we should ensure the consistency between the write and read models. And for that, we should always use asynchronous communication. Okay, the CQRS is in action. So this is just overview of whatever we are talking till now. So the commands side or the write model, it consists of the operation that modify the application state. If we take an example of an e-commerce application, the create order command could go in the command side. So and the next we have query side, so which actually retrieves the data for display purpose without changing the state of the system. So if we take an example of e-commerce application, the order summary view would go in the query side. And the last one is asynchronous communication, which is required to make the read and write model inconsistent state. Okay, and so before going to the demo, I'd just like to talk about the mediator, what mediator actually is. So in the diagram, you can see that on the left, we have API, which is requesting, uh, which will be requesting HTTP, which will be sending HTTP requests like get or post or delete. So the request will go to the controller. And so if we talk about traditional approach, what happens is controller will handle, or controller will know which service to call upon. So if we have a product service and a order service, then controller will create an object of those service, and then what happens is it will call the action of those service, and which performs either retrieving or adding data. But here, in case of mediator, controller only deals with the mediator, and that mediator will define whether to deal with whether to call uh, product service or a product or order service, or more specifically product handler or uh, product query handler or product command handler or order query handler or order command handler. So to talk about that in detail, let me just open my Visual Studio. So I've just created one simple application for the demo purpose. So here you can see on the left, I have two sections over here. One is the traditional approach, another is the CQRS approach. And here you can see the add order, edit, delete, and obviously this is the retrieve uh, retrieve method to get all those data. So similarly, I have all those features here for the CQRS approach as well. I'll be comparing uh, what happens when we perform the same crude operation from traditional approach and what happens when we do it from the CQRS approach. So let's just go to the code for now. So this is one controller for which I've created for traditional approach. So here what happens is you can see that in the controller I am injecting product service and order service, right? And there are few actions that's related to retrieval, adding or updating stuff. So let's just go to add order section over here. So what is happening is whenever we are posting a data or whenever we are adding an order, what happens is this order view model will get those data to this post action. And what's happening over here is we have already created order service from the constructor injection, and we're calling the create order method from of the order service, and we're passing the data to be added. Basically what's happening is, so this is the the implementation. You can see there are a few logics. Sorry about that. Sorry. So these are a few of the logics. We can ignore that. It's related to just managing some stocks and quantities. The main thing that's happening over here is we are creating the object of the order info, and then we are adding it to our database, and I'm returning the order ID. Simple, right? And similarly for, okay, let's see the order list service. Here I have created order service uh, object, and I'm calling get order list what it's actually doing is I'm retrieving data from the database, and I'm just I'm mapping it, and I'm returning the order list to the UI, to the controller. Simple. But now let's go to our CQRS controller. Here you can see the difference. The first thing in the controller is I'm using the mediator class over here. on on the traditional controller, you can see there are two services, and maybe with time we might need to add other multiple number of services as well. So it will just increase the number of codes, and it will increase the dependencies. But here in case of CQRS, I'm only using the mediator, and this mediator will will decide whether to call product service or order service. So how does that happen? So let's just go to the add order post request. Here you can see this is the mediator object that I've created, and what I'm doing is I'm just calling the send over here, and I'm passing the create order command over here. Simple, right? And these these are the data that I'll be adding to our database. So it's coming from here, from the parameter. So what is this create order command? It is a class, and I'm just adding a postfix command over here, and it should be implementing I request, and this int means the return type data type would be would go over here, and these are the data properties that I'm sending, so which I'm assigning through constructor. And so till now, what we are doing is we are only creating the order command, and we're sending it through mediator. That's it. We have not specified any logic of adding those details to our database, right? So how does the system know how to add or where to add the database, add the record to which database? So for that, what happens is, here you can see uh, I have separated my commands in this folder and queries in this folder, and also for the orders, I'm segregating each of the handles by like for create order, delete, update, and all. Let's just focus on create order for now. So we've already talked about this create order command, but now let's talk about its handler. So what is handler? So it is actually just a normal class with a handler postfix. It implements iRequest handler, and this is the most important thing. So in the CQRS controller, we are sending this create order command, and what happens is it will the mediator will look into all the handlers and see which handler is should be used to handle create order command. So it will just look into this parameter of this create order command. Once it finds it, the control goes to this handler, and similarly this is just basic logic about stock, and the most important thing comes from here. So we're just creating a new object of the order info and adding it to the database. Fine, right? So if you see here, I'm using I unit of work. Actually, this will point to one database that's related to, let me show you in the app settings. So I've actually added two different connection strings, which means I'm adding using two different database. So this one would be used to write data, and this one is used to read data, and there will be some uh, synchronizing mechanism to synchronize all the information that I'm adding to this database to the read database. So how does that happen? So here you see, after adding a new order to a write database, I am publishing an event through a mediator itself. I'm just creating an object, and with the help of mediator, I'm publishing that event, and I'm just sending this event. So what happens is mediator will search for the event that I've passed in the parameter, and once it finds it, the control will go to this section over here. What it does is uh, whatever the data we are passing it, it will create object and do necessary logic. So right now we are only just adding the information. So whatever we are sending over here, we're just adding to our read database. So if you see, there's I'm using ICQRS unit of work, which will point to a read database. Simple, right? And let's so uh, we've checked the add order controller. Now let's see how we are retrieving information. So for that, we are okay. Let's see this order list action. So here also we are using mediator object. We are sending what? We are sending get order list query, and what it does, it will just look for its handler, uh, and this is the return type. And whenever it finds this handler, the control will go to this section, and it will retrieve information, map it, and it will return the data simply. But for that, it's using ICQRS unit of work, which means the read database. So simple. So let's test this flow. So the thing is, when okay, so for a few requests, the result might not be that visible. So I'm using a JMeter over here to check the response performances. So here, as you can see, I have created two threads. The first one is CQRS thread, which will point to one database, and or you could see which will just point to the CQRS controller, and another is traditional thread, which will point to a traditional controller that I've already shown you previously. So I've created three requests over here. The first one would be used to fetch all the information. Second one is used to fetch one information, and these are for the create request. Similarly for the traditional, and so if you just see here, I'm actually sending 50 user requests at a time. So let's see how it performs. Let me just clear everything. So it's running. Okay, so let's start with the traditional thread. So you can see that so on the HTTP fetch one request, so it's so for the 50 samples, it's taking on an average of 5,994 milliseconds, right? So let's just see how many uh, milliseconds it's taking for the CQRS thread. So for that, it's taking 1,839 milliseconds. So you can already see the difference over here. And similarly for the fetch all requests, it's taken this time. Similarly for the CQRS, it's taking way much lesser amount of time, right? So this is just for the 50 requests, and imagine having a millions of requests at a time, and in that scenario, you can definitely see how much the system performance increases while implementing CQRS. So that is it. Let's just get back to our presentation. So yeah, this is the result that I have added from while I was testing the JMeter. So I've added request for the add and retrieve for both traditional and CQRS, and you can see the difference over here as well. Now, now the conclusion. So it's it consists of the basic things that we have already discussed so far. It's the first one is CQRS is a very powerful architectural pattern, and it separates the responsibilities of handling commands from queries. And what are its benefits? It provides scalable and performance, flexibility, and it enhances user experience as well. So thank you guys. So any queries, concern, you can bring it on.
Yep. So thank you, Sunny, so much for today's session. It was definitely informative. I'm sure it was helpful, even more helpful for people who actually work in this field. So if you guys have any question, please feel free to unmute and ask your question, or if you feel you want to type it, you also can do that. All in all, it was a very informative session.
Okay, so I do have a question. So in the example you showed the command, class. Can we use record instead of class? Because that would be much simpler. I mean, and they function exactly the same.
Where? So who's speaking, by the way?
Yeah, please
I'm
state your name before speaking
I'm
because
Sanjay Paul.
Sanjay. Okay. So you're saying where? In which part?
Okay, so it was like maybe add product command.
Add product command.
Okay, maybe create order or something like. Okay, maybe create
Okay.
order. Okay,
So this
okay.
is it.
Yeah. So we are using class for it, right? But we can
Mm-hmm.
also use record, which is new
Mm-hmm.
C sharp,
Mm-hmm.
thing. So we
Yeah.
can just for the record, we can just the pass the parameter in the parentheses, and it will just be the essential the same as we have here.
Yeah. So the main thing that is being done over here is to pass the values from the controller to the handler, right? So we can use that. The only thing that's important is we need to pass the same value, uh, class or whatever record you have created over here, and this handler should perform similarly.
Yeah, only the type that matters, right?
Yeah.
And I saw it in other examples, and they were using records, and those were much more simpler. So uh, that's why I asked it.
Okay. Yeah. Thank you for the question.
okay, thank you, Sanjay, for that observation and that question. Okay, anyone else? Any question or anything you want to add in today's discussion? Okay. So officially the session is over.